So we continue to discuss one sample t-test. I would like to apply the test theory for t-test to the example of mass PhD salary. So remember that the t-statistic is important, and the t-statistic is equal to x bar minus our hypothesis 79,500 and divided by s over square root of n. N is the sample size, s is the standard deviation. Okay, so now the hypothesis is the average salary is 79,500 for all mass PhDs in the nation. And the data is given, so we can calculate x bar and s. Okay, so our null hypothesis is here, and the test statistic should follow t-distribution with df6 because sample size n is 7, so n minus 1 is 6. And capital T is here. You can see this is x bar, and this is our hypothesis mu naught, and this is standard deviation 25,000. So this is typical. So this standard deviation is the typical deviation from the mean. And we have seen that all observations are from 55,000 to 110,000. So typically we have deviation of 25,000. So 70,000 is the center, but the typical deviation is around 25,000. So if deviation is maybe 10,000, 20,000, 30,000, 40,000, probably that's pretty usual. And square root of n, sample size is 7. So t-distribution is df6, but here we have to put square root of 7. Then we get the t-statistic is equal to negative 0.94. And we want to see if this number is extreme or just a usual value for t-distribution of df6. And actually, if we see the negative 0.946, that value is actually very typical range of t-distribution with df6. So that means the H naught is nothing wrong. So we don't reject H naught. But to be specific, what should we do? Actually, for a test with 5% significance level, for example, we reject the 5% of extreme values. So that means if we have this distribution, basically we want to reject null hypothesis if it falls in this extreme 5% range. To be exact, if t-statistic fall in lower 2.5% or upper 2.5%, then we want to reject H naught, and otherwise we will accept. So how to calculate this threshold value? So that is actually in the next slide. And actually, if we calculate the value at which 2.5% of the area is below that value, that is negative 2.447. And upper 2.5%, the threshold is 2.447. So that means that we reject H naught if t-statistic t is larger than 2.447 or smaller than negative 2.447. Or we can just say absolute value of t is larger than 2.447. So this threshold is obtained by this Qt function. So Qt function means that the t such as 0.975, then we get this threshold value by Qt function. So actually this is the 2.44. So this area is 2.5% or 0.025. And the other one also the same. So with this, that you can numerically, claim that so capital T, absolute value of capital T is absolute value of negative 0.946. This is the statistic, T statistic we calculated, and this is less than 2.447. So we do not reject H naught. H naught is not rejected. So mass PhD's starting salary is not significantly different from all PhDs, we can say.